What I want to talk to you about today is I want to talk to you about the next wave of virtualization. So over the course of, oh, by the way, yeah, just start here. I'm required to put this up here. It basically says if I talk about anything about a product, you can't imply anything about the future in purchasing. Okay, pretend like I'm lying if I'm talking about one of our products. But I'm not going to be talking about a product today, actually. I'm going to be talking about an open source project that our labs environment has been working on. So do any of you know this? That we actually have a labs group, about 350 people, that work purely on research. And they often open source their projects. I want to talk about one of their open source projects today. It's called Graal. There's a particular problem that we're trying to solve. So in today's agile world, right, things are changing rapidly. You're writing new code constantly. You're pushing out updates many times a day even. And to get the right job done, you need the right tools. And we're making this migration here from these big private data centers and web servers to IoT, machine learning API, and the cloud, and even pushing further than the cloud now, right? There's all kinds, the edge. They're now talking about the edge, and now we're talking about, not even serverless, right? It's just it's getting faster and faster. The pace of innovation's happening more quickly. And even some of the most innovative shops have legacy code. Companies that have been out for 5 years have legacy code that you're dealing with. And there's many different kinds of problems that you have that you're trying to tackle all at the same time. And it's led to, first off, a plethora of languages. There's more languages out there than, when I started programming, there were like literally 6, I think. Okay. Right, there was Fortran and Basic and a few others. Now, it seems like there's a new one every day. I haven't even bothered to try to keep pace with all of the different languages out there. But they all have their particular focuses, right? If you're going to do data manipulation, data analysis, you're going to do something like R, right? So you'll have a problem that you're trying to solve, and you'll want to use different languages to solve each different aspects of that problem. But that also means that you have many different language environments running at the same time. So you're trying to build out more and more efficient data centers, right? You're building containers today. We started with virtual environments, right? VMs, which we're virtualizing hardware, and we're building out containers, which is virtualizing the OS. But yet, when you really look at this problem, and you look at, okay, I'm starting up an R environment and a Ruby environment and a Java, maybe a Node environment, just to get this one problem solved, right? Like I said, Twitter, for example, has legacy code. You want to pick the right tool. You wind up with something that looks like this in your data center, right? This is the different languages that are out there and their usage, right? You wind up with many different languages being used in your data center. In fact, there's so many. Mostly what companies do is they restrict what the developers can use, because you just can't manage it all, and you can't debug it or maintain any of it if you have 30 different languages in use. So you're artificially restricted to using whatever the company says, or maybe your management lets you try a new language or something. And that shouldn't happen, and it doesn't need to happen. Now, like I said, we started out, and we're trying to get more and more optimized. Use more the servers we have more efficiently. Right? We started out virtualizing with a hypervisor that allows us to virtualize servers, which gave us a guest OS. It gave these tall stacks, though. Lots of CPU spent in running 2 copies of the OS, right? One for your VM and one for the underlying host. Then we went to containers, jails, if you remember BSD jails, or Solaris zones, right? Which virtualized the OS layer. So now you could build directly on top of the OS layer and have a lot of the same containment properties of a virtual machine, and yet be more efficient. But when you really dig into this, which is your container, and it looks like it's really efficient, right? Because it's such a small part of all of this, and it's way less than all of this. What you really get into is you get into this. So now you have this host operating system and container virtualization down here, but you have these vertical stacks on top of it. And if you really look here, you have a Java app, a small Java app here. This is all of the resources that are necessary just to get that app up and running. The same goes with Ruby, Python, JavaScript. You have libraries, you have the runtime, you have an immense amount of resources being used, CPU, right, memory, and it just builds and builds, and they're all isolated. Now, when really all you want to do is you want to run this. The rest of this doesn't actually matter to you. It just happens to be the language environment that you're using to get your job done. And if you look, you want to do a hello world in Java, it's 24 megabytes. You want to do it in JavaScript, it's 18. Okay, Ruby's a little better at 8. But that's to say, hi, I'm working, right? So that's still an awful lot of memory just to say hello. And when you start getting into real applications, this bloats fast. So let's zoom in on this a little bit. So what if we could take just one of these stacks? Okay, what does it have? Well, all of those stacks have the same types of services in them. They have an interpreter, they have a JIT compiler, garbage collector, memory management, code cache, scheduler, network access, file system access. If you look at any one of those stacks, what you'll find inside is customized versions of exactly this. Okay? So what if we could share those services? So one problem has been GC coupling, right? So if you garbage collection, one application triggers a garbage collection, bam, everything kind of comes to a halt while it waits, right? And then the other one has been they haven't run on, well, Java's a great virtual machine to do this in, but they don't run on Java well, or if at all. Well, that's where Graal comes in. The boat doesn't have anything to do with it. That was just a beautiful picture, by the way, of them practicing in the Bahamas last month, and I thought I'd put it up there. So Graal is a polyglot virtualization. So what we do is we take and we run on top of the Java runtime, and then we add a layer called the Truffle API. This is a virtualization layer that allows you to build in interpreters for the various languages so you can share the underlying Java services. Right? So then we can build out, and we have built out, a JavaScript interpreter, right? A Ruby interpreter, an R interpreter, Python. And then you build on top of that. Now, the Graal compiler here monitors the Truffle API. And as code comes across through the Truffle API down into the JVM, it actually notices code snippets that are used more than once, multiple times, and will then pre-compile and optimize the code for the code paths that are getting used. Oops. So it monitors that activity, and it keeps these pre-compiled code snapshots. Now, here's the really cool thing about these snippets. If it starts to notice that it was wrong on its pre-compilation, it'll actually tear the pre-compiled code apart and re-optimize it for you. And then it keeps this off to the side so that that code will now run more efficiently. So you build on top of the JavaScript interpreter, say, a Node environment with your application or a Ruby environment. Sounds easy, right? Simple. It's pretty abstract, but it sounds easy. It's actually not that simple. It's taken our many PhDs all over Europe, 6 years, to come to where we are. So, well, doesn't this break security? Well, here's how we solve that. So the memory that each of these interpreters runs in is actually in what we call an isolate. And no memory accesses can happen outside of the isolate. It actually will cause like a bus error, right? An exception if it tries to access memory outside of its isolate. Now, you can set up to access particular memory to be able to transfer data back and forth, actually really quite simply. What about native code? Well, we have an answer for that too, right? We've built an LLVM bytecode interpreter into Graal. And then we can take all of the native libraries from these environments and we convert them into, in this case, the runtime is Java, so Java bytecode. And so they actually run inside. In the future, and this is where, your mileage may vary in the future. I'm about to say, right, in the future, you'll be able to run C and C++ code, legacy C and C++ code in there too. So it'll be encapsulated in an environment where it'll be basically jailed. So it can't be broken into either, or break out of the jail either, all inside of a Java runtime. So this is what it looked like before. This is what it looks like with Graal. You share all the resources that you can, all the way down to the operating system and the container virtualization. And yet you get all of the language capabilities you need inside of the virtual environment. So for your native Java apps, they run here right on top of the Java runtime. For your truffle apps, which are your Ruby, Python, JavaScript, Node, and others, you run them on top. It saves you memory, saves you scheduling power, CPU resources. And the best thing is you can actually link these up now because they're in the same virtual environment directly. So what's one of the common things you do when you have like a common website, right? You'll have some JavaScript up front, you'll have some Ruby code in the middle, maybe you have some R doing data manipulation, right? Data analysis, and you have to write that data somewhere to a pipe or something in some format like JSON or XML or some format that then has to be parsed again, read back in. Well, with Graal environments using the Truffle API, you can actually pass the data directly back and forth. You say, read this as a Java object, or read this as a Python object, or read this as a Ruby object. And it'll read it into the now whatever environment you're in. So it'll take that Ruby object and turn it into JavaScript, or JavaScript into a Ruby object for you. Let's talk a little bit about performance. So this is open source code. Like I said, it's free to use. You can download it from our OTN site. There's a Git repository for it all. So it's still a work in progress. But here's the real performance gains you get. Right? With Java, it's anywhere from 0.8 to 2x faster. C++ can be slow, down to 0.4 to 1.2x faster. That's against LLVM native, for example, there. So I'm not hiding anything from you, right? This is what we really get right now. We're working on making this faster. We're looking to build a community around this to make this really effective and efficient, not just around these languages, but any other languages that you find that you want to use. However, it's not all, and actually this is pretty good news. If you look at Ruby and R here, for example, you could get up to 100x faster. And there's an interpreter called Walnut, which does Oracle SQL. So if you have an Oracle SQL app, you can actually plug Graal into your Oracle database, although don't do it in production these days, because this is open source pre-release code. But you can actually plug it into your Oracle database and optimize your Oracle database queries significantly. And we've seen significant X factors, not quite 100x, but significant X factors there too. Twitter is actually using Graal in their environment right now. They have legacy code. Their legacy code's all written in Ruby. Hard to believe, I don't know, for me anyway, it's hard to believe Ruby's legacy, but there you go, Ruby's legacy. And they're rewriting a bunch of it in Scala. They've actually done a public presentation about this. You can go Google for this presentation and find this graph. This top here is just showing that when you're running Graal, there's two versions of Graal they're running here. So C2 is their current environment. Graal here is the open source version. Enterprise Graal is something I'm kind of gloss over right now. There's a version of Graal that's closed source where there's a few pieces and parts that we're retaining for Oracle's purposes. We are a company, we do make money, right? We've got to make some money somehow. But it's not functionally any different. It's just optimized code. We've built a new VM to replace the Java VM. It's an optimized VM for Graal. And that's the one they're running, actually, that they tested, and they found a 25% boost. So this is the Graal Enterprise here. The orange one is Graal, and the blue one is their current environment. So as you can see here, there's definitely no performance loss and pretty significant gains under heavy usage. And then with the Graal Enterprise, the optimized version, by the way, you can get. You can download it. Everything's in a tarball right now up on OTN. And the closed source code is there as a binary that's available on Mac OS, Solaris on Spark, and Linux on x86. So you can get access to this. We actually did some tests with the WebLogic server, and the green line is Graal. So basic web pages, simple web pages coming up, serving simple web pages. And you can see here, it was about a 10% boost over the baseline WebLogic server. So I had a simple demo for you, but unfortunately there's some kind of security problem I forgot to check today. Something about IP addresses. I can't get to my VM. I had a VM in the Oracle Cloud. Inside of a container I had this, but I actually have the code here. It's a really simple weather demo. This is JavaScript that's going to call a Ruby application to get the temperature in New York. It's hard to read because it's kind of small. This is the Ruby code that calls a website, openweathermap.org data, right? And asks for the temperature in a city name. Here's the from Java string name, so it's taking the name that was passed in there. See New York, right here, New York. It's taking that, passing it into a Ruby string here, and then calling get weather, and it returns the temperature, which would then print out the temperature in New York is whatever time it is, or whatever temperature it is in New York. Unfortunately, like I said, I'd love to show it to you because it was actually kind of cool. It's a Docker container on top of our cloud that ran this. Trying to get to the URLs for this was a little complicated, so I made these handy QR codes for you that you can download. So Graal VM at Oracle, that's where you can get the tarball with the Graal binaries, and you can. It also has the test code, and then here it is a Git. That's all the source code and all the various demos and everything that you can use. One of which is the weather demo that I was going to show you. Plus, there's a weather server demo and many others that'll show you how this actually, you can actually go try it. I went and downloaded it, untarred it, and I was up and running in about 5 minutes. Was able to run some of the demos within about 5 minutes of downloading the tarball. So, and with that said, well, I went really fast. So, what questions do you have? What would you like to know about it? Yeah. Mm-hmm.
And I expect the CPython. So will this work?
Yeah, so in fact, one of the things I didn't mention about Graal is, first off, a lot of the people that work on Graal came over from Hotspot. So you can use Hotspot to dig into it all and actually debug it all. And also, they're working on Chrome. And the API, as you can see, there's the Java compiler that sits off to the side of Truffle. Those same APIs are completely open and available to do analysis yourself. I think that's what you're looking for. So you can actually monitor the code as it's executing through the Truffle API down into the JVM.
Okay, but if I want to actually, so if I want to actually compile the packages that are needed, like I have this Python interpreter, it's probably built in, right?
Mm-hmm.
So if I want to install other packages, like not really like Python package, but some Python package, like for example, like this.
You want to pre-compile it?
FFI, like foreign language interface to, for example, to C or to different language, then just this interpreter supports. So.
Oh, I see. Not like a pre-compile even, but like could convert it. Which? It's been about 6 years since I've written any code, so. Yeah.
I just meant like on the integration part. So how much usable for semi-production is that?
Yeah, well, right now we're not recommending it for production, but it will be production ready. In fact, like I said, Twitter's already using it. So it will be production ready when we go out in the future. There's a lot of ways to see into what's happening inside the VM. And you can even go monitor cross boundaries, multi-language boundaries. So I don't know about exactly like pre-compiling like explicitly. I'll have to go ask somebody, one of the PhDs. I didn't ask that question.
And if I have some code, for example in Java, can I just drop in, replace JVM, and use Graal?
Yeah. 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 Or Ruby, or in fact that's what we. So with the tarball, you get the Ruby and R interpreters. And you just execute them like they are Ruby or R, and they run on top of Graal for you.
Okay, thank you.
Okay. Yeah. Okay.
So I feel like this is the obligatory Oracle question.
Sure.
How are you guys handling licensing?
So this is completely free and open source, and it's available on Git. You can download it. You can add your own interpreter to it. It's always going to be free. Okay. There's going to be an enterprise version that I've alluded to, and we're working on the licensing for that. My intention, and I can't make any promises on this because I'm not the one that makes the ultimate. There's only one product manager at Oracle, by the way, officially. His name's Larry. but unofficially, there's only one product manager. There's one penultimate product manager, Larry Ellison, and he'll determine all licensing in the end. But my intention is to have it always be available for dev and test for free, even the enterprise version. It'll definitely be free. Well, I can't say definitely, but I'm also intending to have it be free inside the Oracle Cloud. So if you're running Oracle Cloud at all, it should be available, freely available there. I'd like to see it available elsewhere. I can't really say where, but you can probably guess.
Okay, so you said open source, but like what licensing? Do you know specifically?
Oh, well, so like,
MIT,
okay, we're
or
working on that
open?
because right now it's under a mixed license because some of the code's under GPL, some of it's under Eclipse, I mean, it's all over the place. And I actually have our lawyers literally right now looking at the licensing to fix it and make it work.
Cool. Thanks.
Okay.
So currently you have, like all the languages I saw you had listed there were interpreted languages.
Yes.
They're basically text-based files that get interpreted.
Yes.
Other than Java, maybe. So you mentioned you were going to support C and C++.
Sometime in the future, yeah.
You going to support a C++ executable, or?
It'll be C++ code that gets converted into the bytecode.
Okay.
Right.
Yep.
At least I think that's the deal, right? Basically what's happening is we're plugging in LLVM into it, and then we're going to have it generate bytecode for the VM that is underlying it. Yeah.
So you said that you were concerned that certain companies would like force you to use, this set of 6 languages because they can't support it, right? So are you worried that like writing your own interpreters for all these languages is going to force people to use the Graal VM implementation? Because I understand that, as languages evolve, maybe like the Graal VM guys are slightly behind, and wouldn't that kind of force you to, like, once your company buys into Graal, you have to use only Graal-supported languages?
Well, so it's open source, right? So actually why I'm here talking about it, even though it's been out there for 6 years, is to get people like you involved, right? So that we don't get behind the curve, because we don't want to be behind the curve. We want it to be, listen, you can go download, you need a special version of the JVM to write expand Graal. It's freely available off the same website that QR code is, okay? But we want you to go out and say, hey, you know what? We're actually working on scale-up, but I need this language, and I want to use Graal, so I'm going to build the interpreter for it. Would love for that to be the case. And our guys took the interpreters and they basically ripped the back end out of the environments, right? So the front ends of those interpreters should be mostly what's available off of the various websites or hubs for those languages. So it should be pretty straightforward to port to it.
This is an unrelated question, but just for my personal interest. Do you have like any plans to make like a complete bare metal Graal where you can like take out a kernel and like say for like super?
So here's the thing about that. So they tried that with Java years
right.
ago, right?
Right,
They tried that with Java years ago. The problem with doing something as high level as a language environment like that is there's just too many variations. I mean, you probably have all encountered, you have two computers that are supposedly purchased at the same time from the same company, but they have completely different drivers, completely different firmware versions, right? Different interfaces. So, now you've got to maintain a back end for all of that. It's just easier to let an OS do that stuff when it's abstracted away for you. There are tricks you can play, right? You can, a certain company up in Redmond's played many of them in the past, right? To optimize a virtual environment or another environment on top of an OS that kind of bypasses the OS in a lot of ways. But then you get into stickiness there too. When I say sticky, I don't mean like glue. I mean like you're stuck, right? You're kind of stuck to the hardware. It gets messy fast. So, not that I can see. I think that, right, if you take container, like I created a simple Docker file for this. Probably took me, my first Docker file ever probably took me an hour for the demo, right? And once I got the thing spun up and working, it was blazingly fast and simple, so.
Thanks.
All right. Yeah.
So can you use any Java VM underneath Graal? Like it's emitting just Java bytecode, right?
Right.
So, is it bound to like Oracle's VM or can
It's
you
not
just use like
bound-
OpenJDK?
It's not bound to our VM necessarily. If you want to do development, there's a particular version of the Java VM that you need. Like if you wanted to write a Graal interpreter, you would definitely need a particular development version of the JVM. It's called like Java CI or something, CN or something like that. It's a bit, like I said, that's available, but you shouldn't be bound to a particular JVM. In fact, the enterprise version has its own version of the Java VM that's been optimized. We've optimized away a lot of the stuff that Graal just never uses.
So it's just like a pared down version of the JRE?
Yeah, something like that, yeah.
Okay. I did have one other question. So does any of this play nicely with like Java 9? Do you know, like,
I don't know, actually. We're working with the Java team. Okay, so Oracle actually has a very, very, very large Java team, and we are working with them. And we're intending to distribute this in as many ways as humanly possible. So one of them might be with Java even. The community version of it might be available with Java directly as like a, do you want to install Graal kind of option.
Oh, you just include it natively like Swing or something?
Yeah.
Okay.
We're definitely going to include it as a RPM for Oracle Linux, which you can download free. You can use our, yum.oracle.com for any Red Hat-based Linux to use our repository and get it for free when it's available later on in the year. Also, Solaris, looking at getting it packaged up for Mac, so you can use a DMG to install it for Mac. These are all things we're looking at, right? We're really early days on this, but we want to make it easy to adopt and use.
Cool, thanks.
All right. All right, well here, let me put the QRs up for you again so you can grab those, because really this is, I've seen a lot of products in the 27 years I've been in the industry. I've worked on kernels, I've worked on the Oracle database, I've worked on virtual I've worked on video streaming servers back in the 90s before the internet was fast enough to really handle it. This is the coolest thing I've ever seen. And I don't even write code anymore, and I think it's, so go get a try. And
So will this work with DSLs, like built on top of,
we'll work with what, I'm sorry?
like stuff like Ruby that's built on top of Java that gets ultimately compiled down to?
Yeah, it should, yes. Yes. And if it doesn't, we want to know about that, right? And you can actually file bugs at Git and let us know. We have a team of, researchers right now, developers that are monitoring the Git repository constantly, pushing new code to it constantly. In fact, there should be, the version I was going to show you is .22, and .23 should be up already this week. I mean, it's supposed to, and I built this demo on Tuesday. So it's moving fast. All right? All right, well, I will keep it short for you, and you can go get booze and food. Thank you all for coming.